Today we're going to go over the physics of drumming. Physics concept we're going to learn today. So first is forces and dynamics, which is free body diagrams, Newton's first and second laws, those forces, and then angular rotation or angular just movement. That will be torque, angular inertia, and kinematics. And then sound waves. We didn't learn this in class, but I'm going to add it. There's waves, and then frequency and pitch, and how that affects how we play. Let's start with forces. So in translation with dynamics, a force is applied directly away from one point. It is represented in free body diagrams. Newton's first law, if a net force is equal, the obvious velocity does not change. And this could mean it's either in constant velocity or it's at rest. And if the forces object on the object all cancel each other out, or there are no forces, then it will be like that. So this is an example of the drumstick resting in my hand. One force is the force of gravity, which pulls the stick downward, and the force normal from my hand, which pulls upward, but there's a net zero force, so that my stick is not moving as it's in my hand, and it's not accelerating. Okay, Newton's second law. So net force on the object is mass times the acceleration of the object. Since F is equal to ma, that's the formula, the acceleration is directly proportional to the net force I'm putting into the stick. So if I want my stick to go faster and hit the drum harder, then I'm going to put more acceleration into the stick. When I'm drumming, the ideal technique is for the normal force to be lessened and to let the force of gravity affect the stick as much as possible, so that I can accelerate the stick as much as I possibly can without putting in any force myself, which gets more fast drumming with less work for me, which is good drumming technique. So that's how this Newton's second law can apply to drumming and making it better. Okay, let's go over rotational motion and torque now. So again, the equation for torque is the force of an object, but the distance away from the axis of rotation, which is the center of which an object will rotate around in torque. In drumming, the axis of rotation is always the fulcrum. The fulcrum is the point in the thumb and the pointer finger where the stick rotates around. That's where all the movement is happening, which is more ergonomical for the drummer. So how the stick moves in this scenario is the force exerted by the wrist and the fingers from the right of my stick here, the axis of rotation. It's called torque, and it's the force that I put into the stick times the distance away from the axis of rotation. Why this is great for drumming: when you have force at an angle, it puts more movement into the stick with less work. If I just went up and down, it would cause a lot of work from my end and more energy and acceleration and force from my end. So we drummers use rotational motion with our fingers and wrist, so that we can have more energy and more movement for less work. Okay, here's a diagram of what's going on. So this is the force of normal and force of gravity, but they don't do any torque on the stick because they have no distance from the axis of rotation. That is the fulcrum, axis of rotation, and then the force applied, that's the force from my wrist and fingers, moving the stick away from the axis of rotation with distance d, so that it can move. Okay, let's talk about moment of inertia real quick. So the inertia is correlated with the mass and the radius. A higher inertia will mean a higher resistance to movement. Because the stick looks like a rod, I will use the rod formula from the center, which is 1/12 mass times the length of rod squared. So which means that a higher mass and longer length rod will have a higher moment of inertia and less resistance to movement. So drummers just like in general to use different sticks for different situations. If we have a more technical piece, we will use a smaller and lighter stick to have less movement and less work from our hands to move the stick, so we can play more complicated beats easier. And then if we have a piece where we need really loud movements, then we'll use a bigger stick. Okay, last topic, let's talk about waves. So the sound from a drum can come in waves. Waves has two properties I'm going to look at today: the amplitude, so like the amount the stick has, the sound wave has, and then the wavelength, which is the period between one sound wave of a sound wave. And then these two factors can determine the volume and pitch of your sound. And then how we hear this audio is at certain amounts the ear can process the waves, and we hear this audio. Okay, frequency and pitch. So the frequency of sound wave is 1 over the wavelength, so it's inversely proportional, which means a lower wavelength will equate to higher frequency. You can see here the lower wavelength between each wave will mean a higher frequency, and this is measured in hertz. And then a higher frequency will always equal a higher pitch. And then this is affected in drumming by velocity and the object you're hitting. If you hit the drum faster, it will have a higher frequency and a higher pitch. You can try this out right now by hitting your desk or something. And then in addition to the object you're hitting. So softer objects will absorb the sound wave and make the frequency less and the wavelength higher, which will also lower the pitch. That's why if you hit something softer, you have a lower pitch than if you hit something hard like wood. Lastly, we'll talk about the volume and the sound, which is correlated with the amplitude. So if you hit a stick faster, and if you hit the drum faster, it will have an increased amplitude, it will produce more sound, and will increase with more force applied from you. Okay, thanks for listening.